Okay, good afternoon. Let's get started. Okay, first, just a quick review of all the homework assignments. Okay, as you know, our course has 5 assignments. Okay, so right now, the last one, homework 5, is due. Okay, so homework 1, 2, 3, those have been graded. The grades are posted in Canvas. So if you haven't done so already, please just go and check. If you have questions regarding the grading or have questions regarding some of the problems you like or the points you lost, just make sure one, of course, if there's incorrect grading from our part, contact our TAs. We will follow up on that. And if there are, of course, issues with some of the challenge questions, then of course you want to make sure you understand them, right, in preparation for the midterm exam. Homework 4, we're working on grading it. We'll try to finish as soon as possible and post the grades. And then homework 5, since it's due right now, so we get to the grading homework 5 right after we finish homework 4. Also, I have asked our TAs and graders to prepare a summary of the common mistakes. So that way, hopefully, you can actually review those and then see some of the questions that may be challenging or where you need some help. Okay, so just make sure you check your grades and check this summary. So that will be helpful in terms of preparing for the midterm exam. Okay, so we're going to post this hopefully, if not tomorrow, hopefully tomorrow. If not, then this weekend, so you can check it early next week. Yes. You don't see it? Okay. Okay, so I'll check because I can see it's published, right? So is it published? You don't see grade, or it's published, you don't see, how to say, you cannot see the homework 3. Okay, all right. I'll check with the TAs, but it's done, so I think we should be able to post it very soon. Okay. All right. These are the homeworks, and then of course the next big thing, that's our midterm exam. Okay, so we're basically 1 week away from the midterm exam. Okay, so today our plan is we're going to do the review. So we'll go over what we have covered right in this course so far, and really highlighting the things that I'd like you to understand, right, and be prepared, right, for the midterm exam. Okay, so starting point, right, I want to say is start with the lecture slides. Okay, because that's basically give you kind of an outline of the things we have covered. Okay. Also, the homework assignments are definitely helpful because for some of the questions, right, you see in the homeworks, except for the programming ones. Okay. That the homework questions are definitely helpful for you to see what type of questions we may ask you. Okay. Textbook, of course, the textbook has a lot of details, right? Some of you already had made the comment to me, I have mentioned that as well, right? So textbook is very helpful. When you go in there, you read particular aspects, but don't worry about reading the whole content, because the textbook has a lot more details, and it's covering some topics that we didn't cover or we didn't cover in detail. Okay, so don't worry about understanding everything from the textbook, but really use the lecture slides and the homework assignments as a guide, okay, to prepare for the midterm exam. Also, I have posted a practice exam, okay, so that's the actual exam we use in fall 2022. So some of you have already started working on that. Some of you said you're planning to do it, right? So that's fine. So basically, just give you a sense of what kind of questions, right, you will see, what type of questions, okay, and also what kind of topics, right, you will see in the exam, okay. So just plan it so that you can, after this review, go review the materials and then find some time to work on that practice exam before Tuesday's class, okay. So on Tuesday, I'm going to go over the exam questions, okay. One other thing is about the exam itself. So exam is going to be a closed book, okay? So don't worry about any formula, memorizing any formula. We will provide the formulas if needed, okay? So that if you're asking a question about a particular formula, it will be provided, okay? So you don't need a formula sheet or trying to memorize that, okay? There'll be no coding and also no calculator, because we don't need you to do the final calculation. So if there are computation problems, you just need to write out the steps, okay? So a Bayesian classification, for example, right? You just write out how you're going to calculate that, okay? But without doing the final kind of calculation result, okay? But just that's also why it's important for you to write out the steps, okay? Because sometimes I've seen students just doing, like say, oh, I need to calculate this combined probability, and that's it, right? You need to show how that then translates to the individual probability that you'll be calculating, okay? So exam time next Thursday, okay? So you have seen the survey, right? So we are doing one in-person session. So that's during the class time here. This is where we're going to take the exam, okay? So that's for like basically have paper copies, okay? And then for the students in the online section, right? And also have students with like special accommodations. So we're now in the process of confirming. So some of you probably have seen emails, right? Either confirmation or we're following up with further questions, okay? So our plan is to finalize, right? For those cases like the exam time, mode of accommodations, all those things, okay? So if you plan to attend in person, like take the exam in person during the class time, you're fine. We still have some students who haven't responded to the survey, and if you need something like Zoom or some other accommodation and you haven't heard us from, like you haven't contacted us yet, please reach out as soon as possible, okay? We want to make sure we have everybody scheduled, okay? All right, so that's about the scheduling, and just yes, wait for confirmation. If you haven't heard from us yet, by now, actually, please reach out, okay? Because we have started like communicating with everybody who need a Zoom or special accommodations, okay? All right, also one thing to note is about office hours, okay? So this is where you still get to like come to ask us questions directly, okay? So our TAs have the regular office hour that's listed, and you can go to our syllabus in Canvas to see the links, okay? For me, so next week I'm making some adjustment, okay? Because my regular in-person office hour is on Thursday, right before the class time. So I figured that wouldn't be as useful. So what I'm doing is I'm switching. So I'm moving my Thursday in-person office hour to Tuesday, same time, okay? Hopefully that'll work for most of you. And then I'm then moving my Tuesday evening session to Wednesday, okay? So basically you would have like a way to say Monday we have a like TA's session, Tuesday we have one, Wednesday actually we have two. Okay, so just know this, right? And do your preparation ahead of time so that if you have questions, you need to come to our office hours, you know when to find us. Okay? Questions? Good? Okay, so two main things as we prepare, right? One, make sure you're scheduled, right? You know when and where you're going to, like how you're going to take the exam, okay? And second, yeah, check the office or check the materials, right? The practice exam, okay? So that you're ready for Tuesday's review and then ready for Thursday. Okay, any questions about the midterm exam? If you have seen the practice exam, I hope like that helps you to relieve your stress a bit, okay? Because the exam is not intended to be very challenging. Basically, if you can follow the materials, so you can like the homework questions and the practice exam. That's really the level of understanding we want, okay? Okay, so today we are going to do a review. Okay, so we have actually covered right quite some content. We're almost kind of 2/3 of the semester. So if you look at like the chapters we have covered, right, starting from the first chapter, that's really just introduction to data mining, and then we started talking about data. Right, when you talk about data set, what's in a data set? You have objects, you have data types, and how you measure the distance, how you like do some kind of statistical analysis, how you do pre-processing. So that's chapter 2. Okay, chapter 3, we started talking about data warehousing and also online analytical processing. Okay. And then we jumped into some of the core techniques, right? So each chapter, actually the 2-chapter combination, right? First chapter is talking about the basic concepts, some of the general methods, and then the second chapter talks a little bit more of the advanced topics, okay? So we have covered pattern mining, classification, clustering, okay? Now, first chapter, so this is a bit like way back, right? So when we started talking about the data mining, first you just want to understand what is data mining, right? We're trying to find interesting patterns, okay, from huge amounts of data, okay? So that then naturally relates to the fact about what do you mean by interesting, what do you mean by like when you work with a huge amounts of data, there's an efficiency angle as well, okay? We also talk about the data mining pipeline, the different views of data mining. We had questions, right, in homework 1, okay? And then we also talk about major issues in data mining, but don't worry about memorizing, because if you go to the slide, we actually have a list of things that are related, right, from both the technical side, and also we'll talk about a little bit of kind of social user interface, ethics, right? So all those are things as you're kind of reviewing the materials, right? Use the slides to guide you, okay? General idea is that if you understand, right, the concept on the slides, that's for the conceptual understanding, okay? And if there are concrete examples, right, doing some computations, those are the things I want you to understand. So you will know how to do the computation given the formula. That's basically the level of understanding I want you to have as you go through the slides, okay? So some of the kind of key points, right? So chapter 1, first the data mining, right? It's about being able to find interesting patterns, okay? So we had quite a bit of the quality versus efficiency discussion, okay? And that actually also will guide some of the later discussion as we'll talk about different methods. We'll talk about the pros and the cons, right? When we talk about the incremental computation, some of the computation complexity discussion, those are all related to the general angle about how you do your work, how different data mining tasks can be accomplished, right, with high efficiency and high quality, okay? The interesting pattern, that's also something I want you to understand, right? Because when you say, okay, I'm looking for some pattern, but what does it mean, right, for that pattern to be interesting, okay? So generally, you're talking about patterns need to be valid. That's important, right? I mean, that is a correct pattern, right? It needs to be novel. Hasn't been discovered before, okay? Potentially useful. This is also why we're asking is about yeah, you have a pattern, so what, right? So you say how this can be useful in some real world settings, okay? And also relate to this interpretability, right? Because ultimately, whatever pattern you find, you want to be able to say how this makes sense, right? How this can be leveraged in different ways. Okay, data mining pipeline, again. This is a visual, hopefully, right? You can kind of understand the high-level thing we're talking about the pipeline is that when you talk about data mining, it's not just modeling. It's not just one step, right? So you actually need to really think about the whole process, right? Going from the raw data, okay? Understanding your data, preparing your data, right? Manage your data, and then be able to pull out the right type of, right subsets of data that's needed for your modeling process. And also, very important is about evaluation, and the fact that this is an iterative process, right, before you go from data to knowledge as your output, okay? The different views, hopefully that's also something, right, that's kind of in your mind now, right? So when you talk about, when you want to describe, right, your data mining project, right? We did all the project proposal, right? So we always ask this question, right? What's the problem? Right, so that's basically what is potential application scenario, right? And then you say, okay, what kind of data you have? Okay, and then what kind of knowledge you're trying to learn, right, from your data, and then of course how do you do it? So that's the technical angle. So those are really the 4 perspectives or views, right? We want you to utilize when you're trying to define or work on a data mining project. Okay. Now, chapter 2. Okay, so this is about data, right? Understanding your data, right? Being able to describe or characterize your data, okay? And then start talking about pre-processing, okay? So when you go through the slides, right, so first we're talking about just objects, attribute types, okay? So by now, hopefully, right, you can know, say when you talk about data set, there are objects. Objects are being described by attributes, okay? But then the attributes can be very different, right? So they have different types of attributes. Okay, so when we think about your project, think about what we have discussed in class, right? There are different types of attributes, okay? And then because there are different types of attributes, right? Now we're talking about how you can measure similarity, dissimilarity, because the fundamental process in data mining is about finding similar items and then differentiating atoms, right? So we're always talking about how you measure similarity, distance, okay, or dissimilarity, okay? So some of the notion, we talk about a few different measures. Again, no need to memorize the formula, okay? But knowing the difference, right? For example, you have nominal values, right? That's different from calculating say the distance using say Euclidean distance, right? Or for say numerical data. Okay. Another thing we'll talk about is like when you have this kind of binary data. If somebody remember, we're talking about whether you have symmetric versus asymmetric, right? Binary variables. Okay. And then if it's asymmetric, sometimes you will say whether you want to consider, right, the null cases, meaning that may be dominating. So if you want to focus on the ones that are like either like have at least like one occurrence like in your data set, right? So those are the things you should consider as you kind of look at the different types of attributes, okay? We then get into the aspect about how you characterize, right, or statistical analysis of your data set. Okay. Again, you can tie this back to maybe the data set you're working with in your project, right? So typically, when you're provided with a data set, you start by understanding, okay, how big is my data set, right? What kind of attributes I have, and then for like here, particular for numerical attributes, right? Or sometimes you can do this for other types of attributes as well. You just want to understand, right, what kind of values, what kind of distributions you see in your data set for the different attributes. Okay, so there are some general terms, right? We're talking about like the n is the basic number of objects, right? So for particular dimension, for if it's a numerical, we ask the mean value, max value. So that's the range, right? And then we're talking about a central tendency and a dispersion. Okay, so central tendency just basically says, okay, if you take that as a whole, what is the most common one, right? So we typically use like a mean, like mean, median, mode, mid-range. So those are just a way of capturing the majority, right? What is the most typical for you to see. But then dispersion gives you a sense of spread, right? You may have like different like attribute value with the same kind of mean value, meaning that the middle point is the same, but the spread can be very different, right? You may have things that are mostly kind of concentrated along the mean value versus things that are widely spread, okay? So we have a few metrics, right, to kind of help you to kind of describe, right, the dispersion, okay? Also, we did some like examples in class, but also we actually have this for your homework assignment as well, right? Some of the graphic display. Okay, so you want to understand, right? So what those graphics are, right? What kind of information they're trying to depict on those graphics. Okay, so box plot, right? We'll talk about box plot shows what, right? They have basically the range, the middle portion, but also have the whiskers, right, to show the outliers. Okay. Also, like a scatter plot, right, is another example, right? We did the homework question, right? So generating scatter plot. But when you have a scatter plot, what are you trying to see, right? So you're basically showing two dimensions, right, two variables, and then they're showing as like dots, right, in this 2D space. And then you're basically looking for potential correlations, right? Okay, so those are just a general idea as you're trying to understand your data. Those are things that I want you to like understand and know what they are, right, when you're trying to describe a data set. And then we get into the pre-processing step, right? So starting point is just that, hey, your data is most of the time, right? Your data is not perfect. So when you take a data set, you'll be looking for, right, some of those like quality issues, right? Either say I have perfect data set, everything's good, right? Or say, I may have like missing data, I may have errors, or there may be some inconsistency. So those are just general issues you want to understand. And then we talk about like various measures for quality, okay? So here, of course, again, I want you to understand, right? When you say like, okay, my data has some quality issues, or I checked my data is good, right, in terms of quality, what do you mean, right? So whether you have like accurate data, so meaning that your like measurements or whatever recording is correct, or you actually have something that may have like say have those miniature sensors, so they may be off by a certain margin, right? So those are all scenarios about what do you mean by the quality of the data, okay? Then we say, okay, there are various right aspects related to the raw data, right? So this now gets into preparing, right, pre-processing, okay? Cleaning. So cleaning, integration, transformation, reduction. So there are a few like aspects, right, we're trying to capture, okay? So again, the things that as you go through the slides, right, those are a lot of this is a conceptual understanding. So make sure you know what they mean, right? What they are, what they mean, why we do this, okay? So here talk about like, if you remember, like say if you have missing values, what can you do? Right? You can throw away the missing values. You can try to fill in with some kind of global mean. You can do some kind of like class-specific mean, or you can even use some methods to kind of try to fill in some of the details, right? Outliers, that's also something, remember, like we'll talk about box plot, can actually help you to find outliers, right? And also, I think on my next slide have this, right? So when you have, say, the noisy data, right, you can try to smooth things out, right? So again, those are methods. We talk about some of the kind of like mechanisms, right? We didn't really ask you to do any particular, I say, computation, right, to do the, say, smoothing or cleaning, but I want you to understand what they're trying to do, right? So for example, like regression, right? Why regression works, right? When you have those data points like plotted, and if you do the regressions, that means like you're basically trying to smooth out, right? Or like remove things that are further out, okay? Clusters, that's another approach, right? Because when you have dots, right, spread out in the space, your clusters help you to find the things that are like the majority. And then again, you can remove the ones that are noisy or as outliers, okay? All right, so this is the example, right? This is like, we talk about like correlation coefficient, we'll talk about chi-square, right? You don't need to memorize it, okay? But we did talk about how you can use, right, the correlation to identify, this in the integration scenario. So when you're integrating different data sets, right, you can try to identify attributes that may be correlated. Okay, so if it's a numerical data, you can use a correlation coefficient, or if it's a categorical values, you can use a chi-square, right? So those are just different ways for you to calculate the correlation, okay? So we did calculation examples, right? We actually had this in the lecture slides, right? And also the homework, so know how to do the chi-square calculation, okay? Giving, of course, you don't need to write, again, you don't need to write out the final answer. We're not giving you, we're not allowing a calculator, but you need to write out, right, to the steps of how you do the, like, expected values and then how you do the final calculation of the chi-square value, okay? Correlation does not imply causality. Hopefully by now you all know, right? So if you have like some way of reasoning, right, you say, okay, like correlation, why correlation does not imply causality, then you can use examples or counter examples, right? Okay, so then we talk about the transformation. So there are, of course, a lot of things you can do, right? So generally just, again, to prepare your data so that your attributes or your data sets are more usable or semantically meaningful for your particular problem setting, okay? So smoothing, that's about the removing noisy data. Aggregation, generalization, those are two things I hope you understand, because aggregation, you're actually taking multiple data points, combining into one, right? Generalization is one-to-one mapping, right? When you have like each object, you're just kind of like generalizing to a coarser granularity, but you're not reducing the number of objects. So although those are useful, but they work differently, right? So depending on what you need for your particular problem setting, you need to like choose one of those, okay? Attribute, feature, construction, this is actually a continuous process, right? The general idea is that like which attributes you use, right? Can you actually generate features or select features that are most useful? And then we'll talk about normalization, okay? So we had this in the homework, right? And also in the lecture slides, okay? So you would know, right? How to do the min-max normalization, how to do the z-score normalization, okay? And also the notion of the normalization is that your original like attribute values may have a particular like a range, right, or distribution. And now through the normalization, now they are aligned like along the same range, okay? But know that min-max and the z-score, they actually have different, right, range that you're working with. Okay, and then we'll talk about discretization, right? So this is when you have numerical data, right? A lot of times for you to do like comparison, right, or finding frequent patterns, you are not comparing the individual, like specific values. Rather, you want to discretize it, right? So that they fall within the same range, or then you have like can convert that into like different like intervals, right? So they're more comparable. So again, there are a few things to do it, okay? No need to like memorize the specific methods. But at a high level, I want you to understand, right? So there, what we call like unsupervised method like split or merge. So the general idea is that when you have like a range, right, a list of values, right, whether you're trying to merge things or you're trying to split things, right? Because basically you take the whole range and you're trying to say decide like which intervals, right, would it be like when you discretize, right, you basically chunk them up, right? Okay, so we're talking about like split or merge, so that means you're merging chunks or you're taking a bigger chunk and split into smaller ones, okay? This unsupervised versus supervised, this basically gets to the point about whether you have some guidance about you should like chunk here or chunk there, right? Because when you are when you're trying to like discretize it, right? Say like do they belong to the same category or something, so that you have some supervised idea. So the entropy base and also actually the chi-square, those are supervised because they're trying to help you to say whether they belong to the same category or they should be grouped together or not, okay? But no need to like say worry about the specific detail. The textbook actually talks about, right, some of the methods. We didn't get into that detail, right? So this is really the level of understanding I want you to like have. This is a slide we talked about, right? Okay, then we'll talk about data reduction, okay? So high level saying that what's the point of doing data reduction, right? The benefit, right? We said like one, if you have, of course, a smaller data set, there's an efficiency angle, okay? So meaning that you may have smaller, your overall process can be more efficient, but it's important that in your reduction process, right, you are still maintaining the representative like data so that the pattern you find, right, using the reduced data set would be similar to what you define with the full data set. Okay, so when you're trying to reduce your data set, right, so there are, of course, two dimensions, right? If you look at like the one side, right, which is the vertically, right, you have the, like each row would correspond to each data object, right? So when you talk about like numerosity reduction, we're saying, okay, instead of keeping the full data set, right, say millions of data points, right, I'm reducing the number of data points I need to capture. Okay, and then on the other dimension, of course, is the dimensionality, right? So those are the individual attributes we're talking about, and say, okay, instead of working with say hundreds of dimensions, can we reduce it to smaller number of dimensions? Okay, so we talk about a few different methods. Again, the idea is that you don't need to get to the say the computation or like a method. Detailed method like level, like how they works, but you need to know, right, there are different approaches. For example, like the data cube aggregation, which actually we'll also talk about later, right? So the idea is that you're aggregating data points, right? So that's why you're reducing your data points. So you may see if you're aggregating by, say, like everything along a particular category, right? Now it becomes one data point. Or if you say, okay, instead of looking at the daily sales, I only look at like monthly sales, right? That's the aggregation you're doing, okay? Another one, so PCA is another example, right? So this is where you're actually taking the original dimensions, but like through your like PCA process, you're basically finding the like the major components, right? So you're basically transforming, right, the original space, right, into a new space via some kind of linear, right, combination, so that your new dimensions, right, would be able to capture, right, or the top dimensions will be able to capture the most informative information in your data set. As a result, right, you don't need to use all the dimensions. Okay, so moving on, okay, chapter 3, data warehousing and online analytical processing, okay? So this is a chapter that has actually a lot more information, and we're not actually, like we didn't cover a lot, okay? So I want you to maybe just remember the high level thing, data warehouse, right? What do we mean by data warehouse? Why do we need a data warehouse, okay? Given that we already have a productional like data management scheme. And then we'll talk about a little bit about the schema, the measures, and then OLAP, data cube, computation. Okay, so some of the high-level points, okay? Data warehousing basically means that I want to maintain something separate, right, for the purpose of decision-making or data mining, right? That is different from the operational database, okay? So that's the key thing I want you to understand, okay? So because of that, right, my data warehouse is intended, right, for this analytical processing, Okay, so we talk about how this is subject-oriented, integrated, time-variant, non-volatile. So just be able to understand those concepts and then be able to reason like why do we mean this is non-volatile? Why can't you do like edit right in place? Okay, so then we had some discussion about how this is different, right? So online transactional processing is more of the operational angle, right? So well, with analytical processing, so we have this table, right, showing how they're different, right? Think about they are tailored for different use cases. So their users are different, the types of data they work with are different, the type of operations are different, the time, duration, or like granularity we're talking about is also different.
What does the T stand for?
Transaction. Yeah, so online transaction processing. So each transaction, that's more like, that's why it's the like operation, right? Real-time operation. I want to say make a change. For example, if you're doing student enrollment, right? When you say confirm your enrollment, that's one transaction. Okay? All right. Okay, so then we talk about data cube, right? So at a high level, right, data cube is just say this is a multi-dimensional representation, right? It's a nice abstraction which allows us to have this kind of general kind of model so that you can then use some kind of general operations, right, on this data cube abstraction, okay? So high level thing, right? So this is for multi-dimensional data representation. We talk about the dimensions, the facts, right? So you remember, if you visualize this kind of 3D, right, data cube, right? So you have the different dimensions, okay? But then in the cells, the values are something that you care about, right? Usually it's the sales, it's the revenue, or like say number of people in that particular category, okay? We also talk about some of the schema, right? So again, this one just understand what they are, right? Because at a high level, we're just talking about, are you talking about a single table? And how, when you connect across out, do you have like multiple steps, right? That's the snowflakes saying, okay? Operations, okay? So we talk about the operations, right? Again, when you're trying to understand those operations, just to say what they do, right? Because when you have this multi-dimensional data cube, right? One understand, we talk about the cuboids, right? The whole lattice of cuboids. That's very important because that gives you a different, level of granularity, right? Because you may aggregate things along different dimensions, okay? And when you do that, right, you have the different levels of cuboids. And then within the cuboid, you have the cuboid cells, right? So that's basically give you a way of kind of like drill down, like getting more specific information, or like roll up, that you can actually get some aggregate information. You can also slice and dice. That basically says that I'm looking at particular dimension for particular values. Okay, so all those are things just I want you to understand as you kind of think about this kind of data cube model, okay? Another thing, this is actually really gets to this efficiency discussion, right? This is about the reasoning. We did this in class, right? So the general idea is that, okay, this is about the materialization. So that means when you have the base cube, right? So the full materialization would basically pre-computing everything, okay? Or you only do partially, right? Or you don't do any pre-computation. You just say, okay, I have my raw data. That's it. When I need to do something, I do the computation on the fly, right? So one thing, this is just a general practice, right? You want to be able to reason about, right, the pros and cons, right? Because here, always you're talking about, okay, so if you do things up front, right, so that means like you're spending your computation offline, okay? So it's the difference between the offline latency or computation versus the online latency, right? Because it's an online request, then we care about how quickly you can return, right, those the answers, okay? But then offline, that means, okay, I'm doing all the computation, whether all the computation is worthwhile, right? You may be wasting your effort, okay? And also, if you pre-compute, right, you need the space usage because now you need to store the actual information you have computed. So those are the reasoning we did, right? So as you review the slides for this particular portion, just say reasoning about the different scenarios and in terms of the efficiency, right? Like the pros and cons in different dimensions. All right. Chapter 4, right? This is when we start talking about some of the concrete, right, techniques, okay? Starting with pattern mining, Okay, so by now, hopefully you know like what do you mean by frequent patterns, right? What is the support, right? What is the confidence, right? So we're using those to kind of measure, right, the significance. Okay, so typically when we're looking for patterns, we're talking about frequent patterns, right? So things that occur frequent enough, right? So to measure that, right, you have this support value, okay, just the frequency, right? But then also we started talking about the confidence. It's like if you see this, right, what's the probability? So that's a conditional probability. So know how to, right, compute those, okay? We then talk about the concrete methods, right? It's about how you do the a priori algorithm, the FP tree. So those are the things that like we all did, right, in class, in homework, okay? Graduate students, you're required to know how to construct the FP tree, okay? Undergraduate students, we had that as an extra credit, right? So you don't have to, but it's also like something, if you understand, that would be something helpful to know, okay? So we had, stuck, oh, okay. So as you talk about, right, the frequent item sets, okay, so make sure, one, you understand the process, right, with a priori algorithm, okay? So the high-level thing is that how you actually grow, right, the patterns, okay? So you generate, right, this is the iterative process. You start with one item set and then go to two item sets and then all the way to K or K plus one, right? And the process that every time, right, you have candidates, but the candidates may or may not be frequent, right? So when you have the candidates, you need to go through your database, check, right, count the support values to then decide which ones are frequent, which ones are not, remove the infrequent ones, generating the next round of candidates, right? So we had all the process and the things that, like, we're using this a priori property, meaning that, like, if your subset is not frequent, right, anything that is the superset cannot be frequent. Okay, and that is what we're using, right, in this particular algorithm, okay? But we talk about, like, because of that, right, the scans, the candidates, the support accounting, so that's like say, yes, I know how it works, but also if you reason about the efficiency, right, that's where we see some challenges, right, and we talk about some ways to do it, okay? So we had actually a question, right, we had actual question using the hash tree. But the other ones, you just need to understand, right? What does it mean? Like how they work, like what's their kind of key properties. For example, we talk about like partitioning. When you do partitioning, you basically just have smaller data sets to work with, right? But with the sampling, right, because you're doing sampling each round, you're not guaranteed to find everything, right? You can use multiple rounds of sampling to increase your probability of finding more patterns, but it's not a guarantee that you find all the frequent patterns, okay? And then hash tree, like that's the example. If you know, like the question in the homework, then I think you have a good answer. Basically, just the idea about how you do the hash tree, right? And the fact that now instead of doing a linear scan of all candidates, using the hash tree, you basically can reduce the complexity because you're basically going down the height of the tree, right? That is the number of checks you need for you to count the support values of the candidates. Okay, so FP growth, so that's the other method, right? So you should all know how to construct your FP tree, okay? And the fact that like using the FP tree, so basically it's a prefix tree, right? The key difference between a priori algorithm and FP growth is that a priori algorithm generates candidates, right? And then check and remove ones that are not frequent. While with FP growth, because you're using this prefix tree, right, you're actually guaranteed, right? So when you see a particular pattern, right, in the middle of the tree, you know everything, like in the prefix, like coming from the root node to this current node has already occurred that many times, okay? That's why you're guaranteed, right, that the patterns you generate are frequent. We also talk about the vertical data format, right? It's just one slide, right? So just understand what it is, okay, what it means, and why it kind of can help you, right, to calculate the support. Because what you basically do is that instead of knowing that going through all the transactions to figure out whether they have this pattern or not, now you say, okay, this item or item set occurred in those transactions. So you can take a very simple intersection, right? So say, okay, I have A here, I have B here. A occurred in those transactions, and B occurred in those transactions. So it's a simple intersection operation for you to find, like A and B occurred together in those transactions. okay? All right, and then we started talking about associations and correlations, okay? So for association, right, we did that in the homework question, right, and also in class as well. So now you know, right, how to find, right, strong association rules, okay? You need to calculate support value, then you need to generate, right, potential rule and check the confidence, right? So that you know whether it's above my threshold. So both the support, the minimum support threshold, and also the minimum confidence. That would allow you to have the association. But then the other thing between association and correlation, there's a difference, right? Because association only says that if A occurs, what's the chance of a B occur? While correlation says that if A occurs, is B more likely to occur or less likely to occur, okay? And so that's what we're trying to capture, that they're like what kind of dependency they have, right? So correlation can be no correlation, right? Or you can have positive correlation or negative correlation, okay? And we'll talk about a few different measures, right? So lift, chi-square, those are all things actually you can use, right, to calculate, right, potential correlations, okay? Again, formulas don't need to memorize, but you need to know, right, how to use this to do your calculation. And once you have your calculation, you need to know how you determine, right, whether they're correlated or not, right? So lift value, right, has the either greater than 1, equal to 1, or less than 1, okay? Chi-square value is always a non-negative, okay, because it's the sum of the squares, right? But it's talking about the bigger, right, or more significant the chi-square value, right, then it's more likely this is correlated and or strong correlation. But that correlation doesn't tell you positive or negative, okay? So you need to compare, right? Basically, you're comparing the observed value and the expected value. So you say if these two variables are strongly correlated, but then to know whether it's positive or negative, then you can see the observed value is like higher or lower than the expected value, because expected value is assuming like no correlation, right? So if you're above or below, then you can determine whether it's a positive or negative correlation. Here also, like we actually talk about quite a few other metrics, right? You don't need to memorize that, but knowing that there's this important notion, right? We have been kind of mentioned this a few times, right? When we say null transaction or null invariant, okay? That basically says that whether your calculation considers all the scenarios, or do you only consider scenarios and then when one of them have occurred, right? So I always use this kind of like the Amazon like purchase or example, right? Think about like if you're trying to see whether two customers are like, or two kind of like types of items are correlated or not, right? You look at how often they're being purchased together, right? Or one has been purchased, the other hasn't been. But you don't care about the majority of the cases that none of those two have been purchased, okay? So that's basically says, okay, like, do you care about the non-transactions or not, okay? So those are the kind of reasoning I want you to understand, okay? All right, moving on. So chapter 5, so this is the advanced topics, right, about pattern mining, okay? So this is where I actually start to use this, right? If you say skips, that means you don't need to look at the slides or how to say prepare, right, those materials for the midterm exam. Okay, that doesn't mean they're not important. Okay, but for the midterm exams purpose, right, you can skip that. So that means I will not have a question as testing on those like content. Okay, but high level, right? So the ones that are remaining, make sure, right? Usually those are more like conceptual understanding, right? We talk about like there are different types of patterns and then like constraint-based patterns. So you need to understand, right? We also have some concrete like examples. Okay. So here, when we say like different types of patterns, right? Then you say, okay, do you have like a single level, right? Because usually when you have different levels, that means just that your granularity can be different, right? We had the example about like milk in general or 2% of milk, right? Or you're talking about like any kind of consumer electronics, or you're talking about like smartphone or smartwatch specifically, right? So when you're looking for patterns, your pattern may occur at a different granularities, okay? So then questions like, okay, how do you choose the right one? Sometimes just like, okay, I'm probably looking at multiple levels. Sometimes you look at the more general level, right? So those are the kind of information you're trying to kind of capture, okay? Multi-dimension, that's basically says like you may have different types of attributes, right, you're working with. You're looking at the age, you're looking at the income, you're looking at like credit rating, all those things where you combine, right, to calculate your patterns, okay? And then quantitative association, right? So this is basically when you, like, we'll talk quite a bit about the discretization, right? It's the same thing, right? So like how you discretize so that you can actually have values that are like comparable because you're looking for frequent patterns, right? So you're not looking for a specific like numerical value. Rather, you put them into chunks or intervals, and you're looking for the frequency of those intervals occurring. Okay. Also, this notion about real patterns, negative patterns. Okay, things that don't occur frequent enough. So that means their support value may be low, right? But then they are still considered, right, important, right? So those are real patterns. So we talk about how you can adjust your support value, right? Because the support value for some general item versus something that is real but important, right, can be different. Also, the negative patterns about things that don't occur together, right? But somehow they have been occurring together. So those are just things like understanding, right? So conceptual understanding of those concepts. Next one, this is actually where we have some kind of questions, right? You have actually worked on this for the homework as well. So this is when we start talking about some of the constraints, right? You can apply, okay? So high level saying, why do we care about the constraints, okay? One, right? For many of your data mining like tasks, you're not saying, okay, I'm interested in everything. You usually have some kind of focused like questions or things you want to look at. So you can use those constraints to say, I only care about those things, right? So that helps with the like overall process, right, of your mining process. So that means it can be more efficient. You'll be finding things that are more meaningful for you, right? That's the benefit, right? Why we want to look at constraints. But then we'll say we're getting into different types of constraints, right? So the high-level thing is that those constraints allow us to zoom into, right, the specific patterns, specific like objects that may be satisfying particular like properties, okay? So there's this angle about the quality, meaning that now I'm finding things that are more relevant, but also this aspect of efficiency because now you only need to focus on a smaller number of patterns or data points, okay? So make sure you review the slides when we talk about like monotonicity, convertible constraints, right? We talk about like convertible generally about when you can sort, right? When you can control the order of items being added, okay? And then we have like what can be strongly convertible, right? So when you have a way of converting, right, into anti-monotonic or monotonic, depending on how you sort things, that's when you say strong convertible. So we had examples in the lecture slides. We have questions, right, in the homework. And I think we have it in the practice exam. So anyway, so make sure you know what they are and you know how to do the reasoning with those concepts, okay? All right, moving on, chapter 6, classification. Okay, so basic concepts, right? We start by talking about what do we mean by classification. We also talk about like this is a supervised learning because you have labels, right? Because you have predefined class labels. Also because of that, right? So with classification, we'll talk about the general process. You have training data. So you want to take the training data along with the class labels, right? You can build up your model so that model can be used for testing. And of course, in the testing scenario, you're only being provided with the attributes. You don't have the class label. And then your task is to determine the class label, right? Okay, and then we'll talk about some concrete methods, right? So those are actually ones that you actually need to know how to do it, right? We had questions in the class, we'll have questions in the homework, so make sure you know how to like use some training table, right, to then construct your decision tree, or you can do your Bayesian classifier, okay? So make sure you understand that. Okay, and then we're talking about lazy learning. This is more about conceptual understanding. What do we mean by lazy learning, okay? What's the pro and cons when you compare that with the eager learning, right? Eager learning basically says that, okay, once I have my training data, I will construct a model, right? So when the model is ready, at the runtime, I just apply the model directly, right, to provide an answer. Well, with the lazy learning is that, okay, I got it, I put it away, or I put it somewhere, right? So I can get back to them soon, but I don't construct a model yet. Instead, I'm just looking at like on demand, right? When I have a question or query, then I'm trying to find like similar things that would then help me to do the classification. So that's the conceptual understanding and the reasoning you need. So make sure when you go through the slides, you understand like what we're talking about when we talk about lazy learning. Okay, and then we get. Let me see. I think I actually have a few slides here. So those are some things just to highlight some of the key concepts I want you to like understand, right? What do we mean by the label? Also, we talk about prediction, right? And then some of the criteria, right? So this is basically say, okay, when you have a classifier, right? What do you mean when you have a good classifier, or when you're choosing a classifier, right? What measures do you care about? Okay. So decision tree. Hopefully by now you understand and you know the process, right? So there are some properties related to decision tree, right? One, it's easy to interpret. Right? If you say, like, I think I had a question like, name one like classification method that would give you a like easy to interpret result, right? So decision tree is a good example of that, because using the decision tree, you can basically explain like specifically how you come up with a particular classification label, right? And then the whole process, right, is about how you do the attribute selection and how you do attribute split, okay? So we talk about information gain, we talk about the split infer and then gain ratio, right? So again, don't need to memorize the formula, but you need to know how to use it, right? So if you take those formula, giving a particular training table, right, for a particular classification problem, you need to write out the steps. So we had examples in class, right, homework as well, exam, like the practice exam. So all those actually should hopefully, like through that process, you know how to do it. Okay. Oh, another thing, if I forget, okay. So another thing we'll talk about is about incremental computation. Okay. So with the decision tree, right, because it's this top-down thing and it's like divide and conquer. So that means you start from the very beginning, right? Once you have made a decision, you made the branching decisions, right? You go to the next level, right? Now, if you had a new data, you basically have to redo everything, okay? Because your branching condition or how you do your branching may have changed, and you may actually choose a completely different attribute with your new data, okay? So that's about being, like not being incremental. So decision tree is not an incremental method, meaning that when you have a new data for your training, then you need to actually reconstruct the whole thing. While with the Bayesian classification, it is incremental because here we're computing probabilities, right? It's basically the statistics of like how things, like the probability of things occurring. So when you have like new data, right, you don't need to redo the probability. You basically just take that, and now you say, look at the new data, you just update your probability, okay? So that's one key difference. Like when you say Bayesian classifies incremental, that means it actually supports, right? That's easy update when you have new information. Okay, and then steps, right? You will have those kind of formula, but the key ideas are, okay, if you have this, right? The key things that you need to know how that turns into the individual probability, right? Because of this naive assumption, okay? So this joint probability, right, of a particular like object with certain attributes, right? Now you need to say, okay, what is the probability of them happening individually? And that's the multiplication we're doing here, okay? So make sure, right, how, of course, one, how to do it, but also understand, right? Because we're making assumption here that those individual, right, or those attributes are independent, okay? That's why we can do this multiplication, right, of the individual probabilities. Okay, and then we started talking about like evaluation, right? So you may have different approaches coming up with your classifier, right? But ultimately, it's how you evaluate, how you choose, right, the best classifier for your problem setting, okay? So we talk about quite a few, right, measures, okay, at a high level. Always think about this confusion matrix, okay? Confusion matrix, this for, of course, for like categorical value, because you're doing classification, right? So on one side, the rows represent the true class labels, okay? And the columns are the predicted, or the classification results by your model, right? So ideally, if everything lines up, then you would have the values, right, only on the diagonal like positions, right? So everything lines up. But whenever you have things that are misclassified, right, that's where you see things like along the two kind of like triangle areas, okay? But then those are not equal, right? That's why we care about this confusion matrix, because like classifying A, like misclassifying A as a B may be different, right, compared to misclassifying A as a C, or vice versa, right? So that's why we get to the discussion of true positive, true negative, false positive, false negative, right? So we have some discussion about how those may not be different, right? If you talk about like detecting like fraudulent activities, right? And also say this like detecting cancer, right? So there are different implications if you make a mistake, right? False positive, false negative, right? Either you like misflag things, okay, versus you didn't flag something that was actually indeed, right, should be flagged. So those are the kind of general just understanding of what they are, okay? And then precision recall, F measure. So those are, again, like formulas, right, we'll talk about, okay? You don't need to memorize it, okay? But we did some, like we had some example in class about like how you calculate, right? If you have the confusion matrix, right, how do you calculate the different ones? So know what they are, okay? And know how to calculate and how they're different, right? So for example, precision and recall are typically used. They're used together because they measure different things, right? So precision is about among the ones you are flagged, right? How many of them are correct, okay? While recall is that among all the true cases, how many of them are actually identified, right? So make sure you understand like those notions and how they're different, okay? Error, right, that's when you're doing prediction, right? Prediction is when you have a numerical value. So in this case, it's not about like one-to-one match, right? Instead, you're talking about how close you get to the actual value. Okay, another very important notion, right? With classification, you have a training data. It's always important that you separate your training data and the testing set, okay? Make sure you're doing this, right, for your project, right? So the high level thing is that how you like pick out, right, your training set. So there are just different approaches, right? You can do random sampling, but make sure, that's why it's called a holdout, right? Because you always want to keep, right, your testing samples away from the training process, okay? But then the different ways for you to do it, right? Hold out because it's a random sampling, right? Just to, even if you do multiple times, you may not have like the, how to say, a robust model. Instead, there's like cross-validation, bootstrapping. So all those are ways of splitting, right? Ways of splitting your overall data set, right, into training and testing. So that's why we also have this discussion of training error versus testing error, right? This also relates to the overfitting, right? So the idea is that if you like build your model, right, as your model become more and more complex, right, you are reducing your training error, okay? But if you overdo it, that means you're overfitting. So that means your model is become too specific to your training samples, right? That actually would impact your testing performance, meaning that your testing error may be higher. Usually we say it higher, but maybe kind of quite higher than your training error, okay? And then we also had the t-test, the RC curves. So we had a t-test for our questions, right? So hopefully you know what that means, but also like RC curve, right? When you are showing RC curve, how do you pick, right? Because RC curve basically is talking about like you can visualize, right, the models, and you can actually easily compare. So what we're trying to look for is actually the top left margin, because that's basically the better performance. So it's like lower. What was that one? So one is about like a higher positive, like higher sensitivity. Like I'm trying to. Oh, okay. So one is the true negative rate, and then that false. G. Okay. I need to remember the specific terms. What we're looking for is that one is the true positives, and then the negatives. So you want to have a low negative rate, no error rate, and a high correct classification. So the top left margin is what we're looking for. So we had a figure showing like different curves, right? If you have like a balanced binary classification problem, so if you do the diagonal line, that is a random guess, right? So you want to do better, right? So basically you're kind of trying to approach more to the top left margin. Okay, and then we're talking about how you can improve, right? Further improve the performance of classification. So the high-level idea we're talking about is ensemble, okay? So the idea is that, hey, I can build one classifier, but I can build multiple classifiers, right? So the general idea is, okay, yes, you have a way, like for example, if you do like multiple runs of like training, right, splitting them with different data sets, right, then you can actually build multiple models, right? And when you have multiple models, it's about how you combine, right, the decisions, right? If they all agree, of course, you're done, okay? But many times they may say things that are slightly different, right? So now the question is like either you do majority voting, right, if it's a categorical value. If it's a numerical value, you can do some kind of average, right? But the high-level thing is that you're combining, right, multiple models like decisions, okay? But also when you're combining, right, the key thing, bagging versus boosting, is that, hey, do you view them equally important or do you view them differently, right? So the basic notion is that one, the ensemble method usually works better than a single classifier. Okay, so multiple model usually works better, right, than single one because they're trying to capture slightly different like perspectives. Okay, but also weighting, right? The boosting approach works better than bagging. Okay, because bagging is really just a special case, right? Boosting when you assign the same weight to everybody, that's bagging. But with boosting, since you can weigh things differently, right? You can actually then like put more weight to like a model that are performing better overall, a model that are performing better on certain like scenarios. Okay, so one, just the notion of ensemble. Second, the difference between like bagging and boosting. Okay, and also the generally when you talk about performance, right? Bagging is better than single one, and boosting usually is better than bagging. Okay, then we talk about advanced classification. Okay, the ones that says skip, so you don't need to worry about. But at this level, right, a lot of this, as you can see, right, you go through the slides, right, we didn't really ask you to do like computation, right, questions on those, but you need to understand what they are, right? This is more about the conceptual understanding. Okay, feature selection, hopefully, right? You remember, like basically, we're talking about how you choose your features, or do like more like a kind of feature engineering. So that the idea is that whether you choose your features ahead of time, then build a model, or you do this kind of iterative process, or you do this in a kind of combined case. So that's generally the high-level idea is about you want to choose your features, right? So that you can use the most informative ones for your classification task. Another thing, like Bayesian belief networks, the high-level thing is why we still need a belief network, right? We already talked about the naive Bayesian classifier. So the key difference there is that when the naive assumption is not true or doesn't hold in general, then you need a specific way of modeling, right, the dependency across different variables. Okay, so with the Bayesian belief networks, you actually construct this graph model. Okay, it's directed, right? Because you have the parent-child relationship, so that means the child depends on the parent, okay? But also it doesn't have cycles, right? Because the parent, your dependency cannot be like circular, because otherwise like it'd be circular dependency and then you would have that method work, okay? Then we'll talk about support vector machine, okay? So generally, right, as you think about the support vector machine, what do we mean, right? What are the support vectors, okay? We're trying to find, right, a way to split, right, or to kind of separate. This is a binary classification, which is important, right? We're talking about a hyperplane, okay? So in the 2D space, you draw a line, you find things right on the two sides. But if it's a high dimension space, you're talking about a hyperplane, but still you're looking at things that are either on two sides of the hyperplane, okay? Support vectors are the ones that are defining, right, the boundaries or the margin. Okay, you want to find bigger margin, right? So that your classifier is more stable and more robust. But the key thing, right, with support vector machine is this like linearly inseparable scenarios, right? Because if you have a simpler classes, you just draw one line or one hyperplane, you're done, right? But in many like scenarios, is that like your original data, right, the dimensions, right, may not be linearly separable. Okay, so then we talk about, yeah, you can do a little bit kind of fuzzy, like do some kind of penalty. So that means, that, yeah, it's not exact, but we're fine. Or we talk about this kernel function, right? How you can actually use kernel function to work with this projection into the high dimensional space. Okay, high level idea is that In the lower dimension space, they are kind of more dense, right? And they're not linearly separable. When I project into the high dimension space, things become more spread out, right? More sparse. Now I can actually find a hyperplane that can separate them. And the kernel function makes it more efficient because you don't need to do all the calculation in the high dimension space, right? Because the projection basically can be accomplished, right, through the operation of the kernel function in the original space. All right, we also quickly talk about rule-based, pattern-based. If you think about, right, saying base is the if-then, right, scenario, right? So if you have a way, what do we call like a rule is being triggered, right? So that means like you have the conditions, right, being satisfied, right? And then you're making decision, okay? But we talk about the accuracy and the like coverage, right? Because at a high level, what you want is a high coverage and high accuracy, right? But when you have to like do some kind of trade-off, right? So you need sufficient accuracy and then higher coverage, okay? We also talk about when you have multiple rules being triggered, right? Then of course, like you need to do some kind of ordering or prioritizing, like which rules would take priority, okay? Also, we talk about how you can use a decision tree, for example, right, to generate, right, your rules. Okay, the idea is that with decision tree, that one thing is very important and useful is that those rules are like they don't overlap, meaning that the conditions, right? Because as you traverse the tree, right, each path leading from the root node to the leaf node is unique. That means they actually have unique conditions, okay? And they cover everything because every time when you do branching, you don't leave out any cases, right? So any of those cases will follow at least one branch. Okay, so all those are some of the properties, right? You want to kind of understand as you kind of review the slides. Okay, weakly supervised learning, we'll talk about a few terms, right? So already we'll talk about, actually, support vector machine, that's when we're already talking about when you have multi-class classification, right? But you have binary classifiers, right? So you can do this like one versus other, or one versus one, so the pairwise classification, right? That's one example. We also talk about like semi-supervised learning, active learning, transfer learning. There was another one. Anyway, so there are a few things, like I think of just generally in a few slides, so you basically try and just understand what they mean, okay? Like what does it mean in those kind of scenarios? We didn't get into any of the specific like methods, so don't worry about like all the more technical details of how those methods work. All right. Okay. Next, cluster analysis. Okay. This one's more recent. Hopefully, still kind of fresh in your memory. High level thing, right? So what is clustering? Okay. We talk about clusters means that one is unsupervised, right? You don't have predefined classes, you don't have predefined categories, right? You're just being provided with the data, with the attribute values, right? You're trying to determine whether they are potential clusters. And cluster-based just means that you're similar within the cluster, you're different across clusters, right? We then talk about different methods, okay? K-means is the one we had actually in the class and example. So you know how you do the K-means clustering algorithm, okay? So you've been provided an example with original data. You know how to do the assignment, right? You know how to kind of like readjust or update your centroids, right? We also talk about the complexity, right, of the K-means methods. So those are things, just make sure you understand and how to use the K-means method, okay? Some important property, okay? The shape of the clusters. Anybody remember, right? Whether it's arbitrary shape or it can only work with, say, convex shape, right? Or non-convex. So those are the kind of properties as you look at the different methods, okay? So for the other ones, we didn't do any computational like example. So don't worry about actually running all those individual algorithms, okay? But we want you to understand, right, how those algorithms are like the high-level properties and at a high level how they work, okay? So some of the things we'll talk about like hierarchical, for example, right? Because it's a hierarchical, right, you can do the kind of bottom-up merging, or you can do the top-down splitting, right? And then it will allow you to find, right, clusters at the different granularities. While with the partition methods, you have to specify, right, the number of clusters up front, okay? We also talk about, for example, grid-based, right? Grid-based is dividing up space, right, rather than the rather than the individual data points. Okay, so because of that, right, the complexity is more dependent on the number of space or cells you're working with. Okay, I think almost the last slide. I'll go through those. Okay, these are just the methods, etc. Don't need to memorize the specific, details, right? We didn't actually really get into all the technical details, right? But for k-means, understand how it works, know how to do it. But for all the other ones, right, the categories, understand what they are and understand some of the key properties of the methods. Okay, last one. Okay, we just finished this, right? So this is the advanced cluster analysis. So that's chapter 9, okay? Some of the high-level things, again, this is really more about the conceptual understanding, right? When you go through the slides, you will see, right? We're talking about the different things. One key thing about this, right, probabilistic model-based clustering, right? We really highlight how it's different from the k-means, right? Very similar to k-means, but the key difference is that with the k-means, you only belong to one cluster, right? While with the probability models, then you basically can have this probability, right, membership, okay, of those different clusters. Okay, so we talk about the EM method, right? Expectation maximization, right? So very similar to k-means, okay? You basically say, okay, you do the assignment, right? Say which one is closer, but then also then you update the models. Okay, so like for example, the Gaussian model, right? You only have those two parameters. You basically look at the mean, you can look at the sigma, and that basically just give you a sense of the cluster, right, in that particular neighborhood. We also have this notion of this mixed models because you don't have just one model, right? Each model corresponds to one cluster. So usually we're talking about multiple clusters, and the combination is the overall clustering results. Okay, and then the remaining ones, except for one that is skip, right? Those are ones really just, again, conceptual understanding, right, what they are. Okay, and that's good enough, all right? Okay, I think that's all for our review, okay? Quick reminder, right? So we have the practice exam. We'll review it on Tuesday, okay? And also make sure, right, you're planned out your schedule. You know how you're going to take the midterm exam. If you still have questions, please follow up with us as soon as possible, okay? Office hours, right? Keep that in mind. I have my updated offers. Please make sure that you're coming to the office hours at the right time, okay? That's basically all we need, okay? See you next week.